Hello friends, today we will be discussing LeetCode problem of the day, that is LeetCode 1519. The problem name is number of node in the subtree with the same label. So let's quickly start understanding what the problem is trying to say to us. Now let's discuss the problem statement. So it is said that you are given a consisting of and nodes numbered from 0, 0 to n minus 1. Each node has a label. For that we will write this one. The root node is the root of the tree is the node 0. Then we can say that each node has a label of lower case character. So what do I mean by lower case character is between the label lie between A to Z, and this label, and we are also provided with a we are also given a label string of length n, sorry, this length n, which will denote label for ith node. So if I say, if I want to find the label for ith node, it will be given by this label string at the position I. So this is pretty much clear to you. Now what we want to return from this function, what the solution, that was the problem one from us. We have to, what the problem is asking us to, we have to return an array of size and where the ith index of the array n will so where the ith will be the number of nodes in the subtree with the ith node which have the subtree of the ith node which have same label. So let's understand this problem with the example subtree or simple subtree. I will be taking the first test case of the LeetCode itself. So it is saying that you have a 0, you have 4, and you have 5, you have 3, and here you have 6. It is given a label A, it is given a label A, B, D, C, E, D. So the label string that will be initially provided will be like this. Yeah, got it. So let's like count what the like let's see what the problem is asking. So for the zeroth node, let's take the root node only. For the zeroth node, we have to count how many nodes in subtree has label subtree have label a. So let's count this thing. You can count it like this node doesn't have a label a, this node has a, so count is 1. This node doesn't have, this node doesn't have, this node doesn't have. So by the way, this is the subtree, like the for this no zeroth node, right? You can see like this zeroth node, for zeroth node this is the subtree, and also the node a itself has a label a. So we can say that the count will be 2. You have to like just consider the root node and the subtree also. Similarly for this particular node, let me go back. Yeah, for this particular node, 2, the subtree will be this thing, right? The label of the root is a, and the child, none of the child has a label a, so therefore the count will be a, 1 only. Why? Because the root has a root has a, so we have to consider the root only. So we can say that in the label, in the like the answer array that we have to return, none of the value will be 0, because we have to count the value of the root itself. So the minimum value of this that thing will be 1, maximum like it will we have to check that out. Okay, so this, I think this the problem statement is clear to you. This example has like made it clear. Now let's discuss like the approach, what we are going to do in this problem statement to solve it. Like, okay, so I'm just writing this approach part here. So let's discuss the approach part. I have taken this sample tree as a to discuss this thing. Okay. So what I'm thinking is, let's try with DFS, because like in tree only you can like get the answer using DFS or BFS. That's the standard thing. So let's for the root node 0, this will be the left subtree, right? This will be the right subtree. So what I will say to these node, okay, you just give me the count of this thing from your node, and this like count of the label in your nodes, and you also give me the count of the total labels in your node. I will club that label, I will club that particular label, and I will find my particular label, and I will add it to the answer vector, right? So what I'm saying, we will maintain an answer vector. I'm asking the left subtree to give me the count of all the label. I'm asking the right subtree to give me the count of the all label, and I will just club those things, and it will give me the count of the all labels like for the root node. Okay, let's discuss this thing. So what I'm saying that, like what we will be doing, we will maintain a vector. We will maintain like for a vector. Let's name it master. Okay, and we know that they are only like 26 character, because the label is a lower case character. So from a to z there are 26 character. And from that, what will we do? We will run a for loop, right, on all child node, and call the same function solve. Okay, this is the function solve. Like I usually write the function name as a solve, so you might have already guessed it. So call the function solve for each child. Okay, so what we will do, we will maintain a master vector, then we will iterate over all the child, and we will call the function solve. And basically this solve function will return a vector int precisely of length 26, because we have 26 character. So that's why I'm like returning the vector int. And what this will do, each child will return its own like local vector, like local master vector, right? So for this like 2, it will return the master vector from 5 and 6 and itself. So we will club all the child. Then what we will do, club all local master vector with the root master. Okay, so this one, like, all the child will return a local master, and what we'll do, we will club all this in this master vector, right? So what it will give us, like, it will give us the total count of that particular character. So what we can say, just like update total count for root label from root master to root, to the answer vector, right? Yeah. So you can see that, like, what we are doing for the root here is, we will just calling for each child, and we are getting the local master. We are just merging into local for the root master, and just we are updating the count. We can, like, similarly do each, like, recursively we can do this step for the root, for like this node, for this node, for this node, for this node. So like what will happening at, like, at the very step, we are just generating local master for this node, then this node we are clubbing to 1, then we are providing to 0. Similarly, we are generating local master for this node. We are clubbing into 1, giving to 2. Then 2 will club it with its local, like, root master, and it will give to 0 node. So this is how we are, like, making our problem into sub problem, and we are solving it. So let's, like, quickly see the solution that I have given to the lead code that was accepted. So let's discuss the solution quickly. So this is the wrapper function that LeetCode provides. So this count subtree is the wrapper function. We are given the number of nodes, the edge mapping, and the string of labels. Okay, just I'm generating the answer vector that we have to return at last. I'm creating an unordered map, like, to create the tree basically from this edge vector. So this is like the basic logic for creating the tree, because it is undirected. We are just pushing the tree to each each back, each edge. So this is like pushing it to the each edge in the map. Then we are calling the solve function. Basically the solve function is the heart and soul of this basic problem, and, like, it is solving this problem basically. So okay, so the solve function will take the reference to the tree, so that we have created here using the mapping, or the edge mapping. Then we are taking the string of the labels from, like, it is provided to us. Then we are taking a reference vector to the answer. So we will be updating our answer vector here only. So that's why we are taking the reference vector. So we don't need to pass, like, answer vector every time. We're just passing it the reference of the memory of it. Then we're taking the current node and the parent node. So this thing is basically for removing infinite tube, or the TLE case. So we have to keep a check that from the child we doesn't go to the parent. So that's why we are taking these two vectors. Okay, so what I'm doing, I'm just okay, let me clear this thing. I hope that you have understood, like, what I have, like, taken inputs and why I have taken the input. Okay, let's start. So I'm creating a local master vector for each node. Then what I'm doing, I'm updating the local master with the current label. So as I already discussed you, that the answer vector that we are going to return will have the minimum value of 1. So that's why, because the we are updating the label for the particular count in the master vector. So, like, particular label for the root is updated as 1 in the master vector. Then we are creating a temporary vector. Then I'm calling for all the child of this particular node, and I'm checking that I'm not calling for the parent, because this will lead to this particular TLE, or this infinite loop case. Then what I'm doing, I'm just calling the solve function with all the parameters. I've just updated a child and the node, you can, or the parent, you can see. Then this solve function will return me a temp vector. Then I will iterate over the temp vector, and I will update my root master. So I am getting a local master. Yeah, you can say this is a local master of child. I'm just merging it with the root master. Okay, or else we can say it as merging root master with child master, right? Got it. So we are doing the step for each child. So after doing this step, we will get, like, the what the scenario of the labels in that particular route. So what I'm doing, I'm just updating the answer. We got the answer, like I'm just taking the our master is updated. I'm just taking that particular root character or the label, and I'm updating with the answer node. So the node is the numbering for the root, and as label of node minus a, so it will be a character, and character minus character will give you some sky value, I guess. So as according to that sky value, I'm picking the master, like what is the like particular value. So if I say like I want to, I have a label of a, and if I do a minus a, it will give me 0. So at the 0th position of the master, I have the answer for the a, or the for the label a. Similarly for b, you can check a minus a, it will give me 1. Sorry, it is not sky here, I by mistakenly wrote it. Okay, so it will give me 1, and so I can say at the master's like first or the one index, I will get the value for the b. Similarly, you can check for any of the index, like for any of this thing, any of the character. So that's how I like updating this thing, and I'm returning the master to the from here I'm returning the master to its parent. So like this master will go to this particular node's parent. So that's how like I'm solving this particular problem. I guess this problem gave me like around 70% beat, and the memory limit is like memory consumption was quite high, like because this problem we are generating the local master and master variables, master vectors. So that's why this memory uses will be high, while the official one also had high memory uses. So that's like we have to use memory to solve this question, but the time is 70%, which I guess like it's quite similar to the official one, like quite close to the official one. So this was my solution for this like problem. And if you guys had any doubt in understanding any concept, you can just write in the comment. I will try my best to like answer your queries. So like you can this was my solution basically. Okay, okay, then bye. Meet you tomorrow with the new LeetCode problem.